A lot of people use the geological evidence to prove to young Earth creationists that the Earth and the universe are more than 6,000 years old. But what about the cosmological evidence? Why not talk about the billions of galaxies in the universe that we can see everywhere we look? And they're located millions and billions of light years away from the Earth. According to NASA, the Hubble Space Telescope's observations were used in 1999 to come up with an estimated 125 billion galaxies in the universe. The furthest one, and therefore the oldest, that has ever been observed is located 13.2 billion light years away. This means that it came into existence barely 480 million years after the Big Bang. As for the youngest one, it is a mere 500 million years old. Therefore, my question to the young creationists is, how did the light come from those galaxies reach us? If the entire universe was truly located within a 6,000 light-year range around the Earth, it would be a very crowded place. The fact that we can see so many distant stars and galaxies is proof enough that light had to start traveling toward us an incredibly long time before the mere 6,000 years when God supposedly created everything. That's why I decided to discuss the Big Bang Theory in a video trilogy. I will try to explain it in a way that non-physicists like me can understand. Hopefully, I will do the job right and won't lose anybody along the way. This story could start thousands of years ago as humanity tried to comprehend the universe. Instead, I'll start in the 20th century when Albert Einstein came up with the theory of general relativity. But please, first allow me to begin with a small trip back in time in 1687. That's when Sir Isaac Newton published his law of universal gravitation. Why the detour? It's because gravitation started the ball rolling for the Big Bang Theory. Newton suggested that there was a force between bodies that attracted them to one another. His explanation made plenty of sense to the scientists of his time, and kept countless others satisfied for more than 2 centuries. But the great man himself was not at all happy about it. He disliked the idea of having to use an invisible force affecting planets through the emptiness of space as an explanation for gravity. Although he was displeased with this awkward cause for gravitation, he added, "I have not yet been able to discover the cause of these properties of gravity from phenomena, and I feign no hypotheses. It is enough that gravity does really exist and acts according to the laws I have explained, and that it abundantly serves to account for all the motions of celestial bodies." Now that we have discussed Newton, we can go back to 1915 and Einstein's theory of general relativity, where he unified the concepts of time and space into a fabric engulfing the entire universe. Thanks to Einstein, gravity is no longer considered a force, but an attribute of the space-time fabric. According to him, a mass distorts spacetime just like a ball distends a cloth on which it is placed, and influences everything that comes close to it. Not only are masses affected, but so are light and time. For people who understand his theory, using a global positioning system device is proof that Einstein was right about the effects of gravity on time. If his theory of general relativity was not included in the GPS's calculations, the results would be totally useless and locations would not be off by mere meters, but many kilometers. By 1919, scientists were still looking for proof that Einstein was right. One of them, the British astronomer Arthur Eddington, led an expedition to observe an eclipse. He took pictures of the sun and the stars surrounding it. If Einstein was right, the light of the stars located past the sun would be bent and appear to the viewer in a wrong location. Eddington repeated his observations of the same part of the sky 6 months later, and, exactly as Einstein had predicted, those stars looked like they had moved. When the results of Eddington's expedition were published in 1920, Einstein immediately became famous, but in all his calculations, he took for granted that the universe was static, as per the general beliefs of his days. This turned out to be what he later called the biggest blunder of his career. And that's it for now. The next video will tell the story of a priest who came up with what he called the day without yesterdays. Thank you very much for watching this video. I would ask you to take a second to rate and add your comments. If you haven't subscribed yet, I invite you to do so. There will be plenty of both interesting and funny stuff ahead.